All right, so it is now Wednesday, April 9th, and we are on day 11 in Algebra 1. I know. It goes fast, guys. It's pretty crazy. So, for your do now, I give you 4 problems. First, 2 equations that you draw the graph of. And for the last 2, I gave you the graph and you write the equation. So, let's start with number 1. Our first equation is y equals negative 1/2 x plus 3. What do we need to do first? Plot my 3. What is this 3 telling us? It's positive, and what is this called? The y-intercept. So my y-intercept is positive 3, so it goes at 3 on the y-axis. And I forgot to label those. There's my y-axis. Yeah. Hey, if we can figure it out without me labeling it, that means you guys know it better than we all think. So that's good. Okay, so we have our y-intercept graph. Now what?
Go down 1 and over 2.
Down 1 over 2. How did you know to do that?
Because it's negative 1 over 2.
Because negative 1 over 2 is the number next to x here. This is our slope. So, negative 1 tells us to go down 1, so 1. And 2 will go over 1, 2. And here is where my next point goes. What's my last step?
Connect the dots.
Connect the dots. Very nice. Okay, does anybody's graph look a little different than mine by chance? Or do they all look just like this? Did everybody get this? Perfect. Good, 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 good. All right, let's look at number 2 then. For number 2, I've got y equals 3x minus 2. What's the first step?
Minus 2 on the y.
Minus 2 on the y-axis. That's our intercept. So we're going to go down to negative 2 on the y-axis. And what do I do next? Yeah, up 1, 2, 3, over 1. How did you know to do that?
The whole number.
Because
Uh-huh.
the 3 doesn't have a number underneath it, and it's always going to be 1.
Yes, if our slope is a whole number, if it's not a fraction, we turn it into a fraction. 3 is the same as 3 over 1. So that means we go up 3 over 1. Now this one can be tricky sometimes. It's easy to forget what to do when you have a whole number slope. So this is a good reminder. When you don't have a fraction, to get your run, we need to put it over 1. It kind of rhymes too. You can think about it. When there's no run, your run is 1. There you go. No run, run is 1. So now we'll just connect our dots. And we have a beautiful line. There we go. Perfect. All right. So there's number 1, and there is number 2. Now, I didn't ask you to do this, but just for a little extra practice, just for fun, let's name some coordinates. Back at number 1, we're going to start with the y-intercept at 3. Since we're touching the y-axis at 3, that should be a pretty good hint that our y value is what? 3. What's our x value? 0. Good. How about this point? My x value is 2. We're lining up with 2 on the x-axis. And what's our y value? 2. Good. So 0, 3 and 2, 2. Very nice. Okay, now let's look at these coordinates. Start with the y-intercept.
0, -2.
Beautiful. 0, -2. Perfect. Now how about this point? 1, 1. Oop, 1, 1. There we go. We line up with 1 on the x-axis. We line up with 1 on the y-axis. Good job, guys. Okay, do we have any questions about the first two problems? Any questions? We feel good about them? Okay. Okay. If we have questions that happen to pop up later on, you can interrupt me, stop me. I want you to use this time to learn things. And sometimes the best way to learn is by asking me when you don't know something. Actually, I'm going to say that is the best way, is by telling me you don't get it so that we can try something different. So, perfect. That is number 1 and 2. Let's now shift down to number 3 and 4. Now we have the line already drawn. So we're going to move backwards and write the equation. And I already started it with y equals for you. Just to remind us that that's what our equation will start with, y equals. So when we want to write an equation, what are the 2 things we need to find on our graph? Slope and y-intercept, yes. So we need a slope and we need a y-intercept. Okay, so which one do you guys want to find first? The intercept? Okay, so what's our y-intercept here? 2. Good. That is where the line touches the y-axis, and it touches it at positive 2. Okay. So, how do I find the slope now? -2? How do you get that? How do we get our slope? What do we do to find it? We need to count our spaces. We need to count a rise, how far up do we go? Then we need to count our run, how far over do we go? So I'm going to pick 2 points, any 2 points. How about we start with our y-intercept? We'll start right here. I'm going to zoom really close in so we can see what's happening because these points are close together.
Going up to
Up 2 over 2? Yeah, that would work, yes. We could do that. We can pick 2 points. They don't necessarily have to be right next to each other. So we're starting at 2.
rise to
Mm-hmm.
and run to.
So we could rise 2 if we wanted to. And let's say we do this one,
Get that.
over 2. So if I go up 2 and over 2, my rise is 2, my run is 2.
You could also do the 1 over 1.
You could also do 1 over 1. This is the also same thing as 1 over 1. These are equal to each other. And you could also see that by, let's use 2 different points. How about these bottom 2? How far up do I need to go? 1. So I went up 1 and over 1. So we would also have the possibility of saying 1 over 1 for our slope. Both of these are correct. The difference is that this one is simplified. 2 divided by 2 is what?
0.
Not 0.
1.
1. 1 divided by 1 is what?
1.
1. They're both equal to 1. They both work. So technically this is also correct. They both work. Okay? But it's usually nice to write a more simplified version. So we could write 1. We could write 1 over 1. I would accept 2 over 2 though. That is also a good answer. It's correct. So I'll write 1 over 1, and I'll also say or 2 over 2. I'll take either. Or you could write just 1. That's also fine. I'm good with any of them. Now before we go on to writing the equation, do we have any questions about how we got either of these numbers? Okay. How do I write my equation?
Y equals 1 over 1 x opposite 2.
Yes. So it's y equals the slope, 1 over 1, and then x
Opposite 2.
plus our y-intercept, which is 2. So y equals 1 over 1x plus 2. There are multiple ways to write this equation that are still correct. I can show you a few of those ways.
Miss Taylor,
Yes.
so it really doesn't, I mean, it does matter, but as long as you start on the, on the axis for the y, to find the y-intercept,
Mm-hmm.
just as long as you hit the points.
Yes.
basically,
Yes.
So you can go either like what you just done.
Yes.
Okay.
To find the slope, you can pick any 2 points at all, as long as they're both touching the line. It doesn't matter if they are, like I could have gone all the way from here to the top point, and I could have said my slope is 1, 2, 3, 4 over 4 if I wanted to.
Okay.
It's all the same thing. Yeah, that's a great question. So it's really just y equals 1x plus 2. You could write, so I'm going to say 1 is equal to, you could do 1 over 1, 2 over 2, 3 over 3, 4 over 4. If you put a number over itself, it is equal to 1. Any number divided by itself is equal to 1. That makes sense? Okay. So that's our answer. Wonderful. Should we try number 4? Okay, let's look at 4 then. What should I find first?
The y,
Y-intercept. What is my y-intercept?
-3.
-3. That's where I touch the y-axis. So I'm going to write over to the side y-intercept, or my b. Let me make that clear. It's a little blurry. Okay, that didn't help. Hang on. There we go. -3. And now we need the slope. How do I find my slope?
Rise,
Rise over run. Perfect.
go up 3.
Up 3 from here? Okay, sure. Up 1, 2, 3, and over 1. Now, since I went from right to left, I did it kind of in the backwards order. We need to keep in mind what the sign of our slope will be. It will be negative. So 3 and 1, we have a 3 over 1. Since our slope points down, -3 over 1. Now, if you're worried about remembering the direction, telling us the sign, I would say always start from left to right. So maybe we could pick 2 different points, like this one here, and I would see that I go down 3, giving us that -3, and to the next point, over 1. And that gives us the same thing, negative 3 over 1. And that's our slope. We could also just say our slope is negative 3. Same thing. Okay. Any questions about how we got either of those values? You got a question?
Yes,
Tell me.
why did we count that dot up at top? Why did we go to the other dot instead of where that y-intercept?
Why did we go here instead of the y-intercept to this dot?
Yeah, why did we go from the second dot to the second dot instead of y-intercept?
So the reason I showed this way as well was so that we could see how we're going down 3 when we go left to right. Whenever we count from the y-intercept, since there's not another point to the left of it that I have drawn, we won't be able to show that we're really going down with the line because you counted up 3. We could think of it this way though. We went up 3 and then left 1 instead of to the right. And since we went to the left, we would say that our 1 is the negative value. Either way, it gives us a negative slope.
But in order to get the slope, the run, I mean,
Mm-hmm.
less than slope, you have to go from left to right.
Yes, I will say left to right will give you probably the most reliable answer, since that is for sure going to give us that downward motion if we're going down.
So it's the close.
But if you go right to left, it'll still work. You just will need to remember that since our line is tilting downward, it's a negative slope. Because sometimes I have students that like to do this. You're okay. I have had students that like to not worry about the signs while they're counting. They like to just get the numbers, and then they ask themselves during kind of like a second step, okay, now, is this a positive slope? Is it pointing up? Or is it a negative slope? It's pointing down.
So they basically just check it.
Yeah, and that way there's less things to think about, like, okay, well, I got my y-intercept. Do I need to move to a different point now, or do I need, so they just count the spaces between the points, and then they think, okay, well, it's tilting down, so it must be negative. Yeah, so we can do something like that. So we've got our y-intercept and our slope. How do we write the equation?
Negative 3 over 1.
Hmm.
Negative 3.
We could say y equals negative 3 over 1 x plus negative 3, or we could just say minus 3, negative 3. That's our equation. Here we go.
You could also just write negative 3x.
Yes, you absolutely can. And if anything, that's actually a better way to write it. We don't want to put things that we don't necessarily need. The only reason I am not stressing that yet is because I don't want to put too many ideas in our heads all at once, because I know it can be hard to juggle them all. But later on, when we get into, trickier stuff, it'll be good to know that whenever you have something like negative 3 over 1, it's the same thing as negative 3. It's the exact same. It's just written differently. We don't really need the 1. Will I count it wrong? No. But simplified is always better. Makes it easier for everybody to understand. I dropped my pen. Okay. All right. Now, before we move on and do some practice together, I want you guys, just as a class, to take a moment, look at everything we just did, and I want us to come up with 2 really good questions about this. Even if you totally understand it like the back of your hand, come up with a question that you think would help one of your classmates. So think on it. When you think you have a question, you can pop your hand up or just shout it out, and I'm all ears. Try and come up with a question about what we just did. Yes.
I know, I'm stupid, I'm sorry, but,
No.
I know you got your lines and arrows, right?
Mm-hmm.
Well, how do you know they're going down or up?
That is a great question, actually, because I might be saying this and I'm assuming you know what I mean. Let's get into that. Brian says, what do I mean when I say the line is pointing down or the line is pointing up? Let's talk about that. I'm going to pull out a graph. Whenever we are reading, whenever we're writing, doing anything, we go from left to right. That's something that we're going to get drilled in our brains. We go from left to right. So, I'm going to start with a line that goes like this. If I want to start on the left side of this line, should I put my finger over here near the negatives or over here where the positives are? Negatives. Let's start over here. Here's the left side. So whenever I start over here at the left side of my line, if I trace the line, is my finger moving up or down? Up. So, will this be a positive slope or a negative slope?
Positive.
Positive slope. Positive slope. Now on the flip side, if I have a line like this, and I start here
Left.
and trace, start from the left side of the line, and I trace over to the right side, watch my finger and tell me, does it move up or down?
Down.
Down. This is what I mean by the line goes up or down. So there's down. And what kind of slope will this line have? Negative. So if you find it hard to keep track of the positives and negatives while you're counting your rise and run, just count the numbers and then ask yourself, is this positive or is this negative? There we go. And I think sometimes just the act of tracing your finger along the line can be a really great reminder. Just touching the left side of it and moving it, watch it, you'll see that your finger moves up. Starting here, tracing it to the end, you'll see your finger goes down. Does that answer your question, Brian?
You did.
Good.
I was curious, will we ever have a negative number for a run?
Yes. If you are keeping track of the numbers as you go, like in, let's see, let me give you an example. I see some of us are still writing this. I'm going to give us just a minute, and then I'll give you an example for that. So, Brian asks, will there ever be a negative run? Let's see. Technically there could be, but if the run is negative and the rise is positive, you still have an overall negative slope. And I'll show you what I mean by that. Let's say I am looking at a line that goes through these 3 points. Okay. And I'll go ahead and draw the line. really got some black on that pen. Man. Okay, so if we went from right to left instead of left to right, we would go up 3, making our rise 3, positive 3. But the run always goes to the right, always. And the run we say is always positive, unless we have to move to the left. If I go to the left, notice on the x-axis, when I go to the right, my numbers are positive. When I go to the left, my numbers are negative. Just like when I go up on the y, I have positive. When I go down on the y, they're negative. So if I go left in the x direction, my run becomes -1. But if I have a rise of 3 and a run of -1, 3 over -1 means 3 divided by -1. What is that? 3 divided by -1? It's just -3. So technically, yes, we could say that the run is negative, but it's just telling us that the whole slope would be negative in all. Does that answer your question?
A lot of info there.
A lot of info, yes. Basically, I wouldn't worry about the specifics of the run versus the rise being negative and positive if you are able to remember that when it goes down, the slope is negative. When it goes up, the slope is positive. If these two items can stick in your brain, you will be in excellent shape. These are kind of the main ideas.
You just gotta remember to go left or right on everything.
Yes, left to right is the way to go.
Okay.
Always. That's the best way to do it. Okay. Any other questions?
That kind of answered mine. I was like getting stuck on, like with the rise and the run, like on some of them we've started, like you have to start at the y-intercept to be able to find the slope. But
Mm-hmm.
in a situation where the already is, like if you can pick any of the points. I kind of think that's might have been what he was saying earlier.
Okay.
Like, what's the difference between having to start at the y-intercept and being able to go
So,
anywhere else?
you actually never have to start at the y-intercept.
Okay, was that just like a way to?
Yeah, sometimes
Okay,
it's
okay.
just a great way to start because
Okay.
it's like, well, we already identified it, we're here, let's just go from where we are.
Okay.
But whenever you're finding slope, you can actually use any 2 points on the
Okay.
line.
Okay.
Doesn't have to be y-intercept. So,
Okay.
hopefully that answers both of those a little. Yes.
That also answers.
Good,
Okay.
good, yes. You don't have to start at the y-intercept.
Yeah.
You need to always identify the y-intercept because that's part of the equation, but for slope, you don't have to start there.
Okay.
Any 2 points.
Okay,
Good.
because it's gonna keep repeating.
Yes, yes, and that's a great way to think of it. If I have a line, watch this. I'm going to do another one. Yeah, you don't ever have to start at the y-intercept. Okay, so here's another line we'll look at together. Yeah, so what's the y-intercept, first of all? It's 2. Good. Now to find my slope, I do not have to start here. I'm going to show you how we can use any of these points. If I start here, I would, to get to the next point, go down 1, over 1, 2, 3. So 1, but it's negative since we go down, and 3 over, what would my slope be here? -1 over 3. I could use these 2 points. Let's say I want to use this point and the y-intercept. I still go down 1 over 1, 2, 3. I still from the y-intercept to the next point, down 1 over 1, 2, 3. Same here, down 1 over 1, 2, 3. You can use any points. Now, can you use like the first point and the last point? You can actually.
Can, but you're gonna have to reduce it.
Yes.
after you're done.
So let's look at that. If I decided to go from here to there, I'm going to go down 1, 2, 3, 4 over 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So I went down 4 over 12. And guess what? Negative 4 over 12 is the same thing as negative 1 over 3. Now, does anybody want a more in-depth explanation of why these are the same?
No, explain.
That's a good answer. I'm done, you don't have to go any further.
It's just
Yeah.
like
You divide it,
simplifying
just what
fractions,
you
right?
do.
We're simplifying fractions, that's it.
Yeah.
It's like you're taking out, you're dividing both of these by 4. Divide by 4. Negative 4 divided by 4 is negative 1. 12 divided by 4 is 3. But if you put this as your slope, I'm not going to count it wrong. Okay? I'm not going to count it wrong because they're the same. Both of these are good. They're both good. You can pick any 2 points. It does not matter. It's all the same answer. You're just trying to see what angle does my line go down at. This is telling me the same angle. It's giving me the same line. Does that make sense? Okay. 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 All right. Now, let me ask you guys this. Do we want some more practice counting slope?
No.
No? Because I was ready to move on, but with all the questions, I just wanted to make sure I'm not reading the room wrong.
No, you clarified pretty well.
Okay. Okay, cool. Cool, cool, cool. Let's move on. All right. And if you do want more practice, you can always come and see me after class or on Fridays. We can focus on anything you want to learn. So, that was the do now. And this. Yes.
So in math, we're doing all these slopes and graphing, but in some of our everyday life, we don't use graphs. So why
Yes.
is it necessary?
Good question. So, I always like to give this analogy because to me it's what made it kind of click in my brain. So, imagine you are a football player. Not very relevant to any of us, but let's think about it. Football players, when they are in high school, or any sports person, high school, college, in the big leagues, whatever, they do conditioning where they lift weights, where they run. Now, running is relevant in football, but lifting weights is one of the big things they do in conditioning. Do they need to lift weights on the football field?
No.
No, they will never use that skill in their real life, but it's excellent exercise and it's making them stronger. This is the same thing. You're not ever going to use this. I'm going to be honest, you won't use it.
That's
You
why I'm
probably
saying,
won't.
like, I see everyday people that using graphing.
Yes. Now there's ways to use this. I can show you ways that we can use it, but it would be more of a for fun thing. Like, you won't need this.
Right.
What it is that exercise for your brain. What you're learning in here is how to problem solve and persevere and how to do things that you don't think you can do. Because that ultimately is the greater lesson here, is that you guys come in and something that looks terrifying, you do a really great job at it because you're putting in that effort, you're persevering. Even though it's scary and it feels hard, you're doing it. And that skill you use every day. Not the math, but the skill. It's exercise for our brains.
I was just wondering.
No, it's a good question.
Like
None of my
graphing
brains
or
hurt
graph or
someday.
anything in real life, so I was like, why is it necessary?
Right. Now, why is it necessary? That's the question that I wish I had the answer to. All right, we're going on break. Come back at 2:05. That's that, and we are back from our break. So I'll move that. We did our do now. We talked about slopes being positive and negative. And we've been doing quite a bit of work for the last few days with graphs. We're going to take a little break from them I'm gonna go back to lined paper. Yay!
Love that.
Yay! So, we're gonna learn one more thing today. And it's still about slope. So, let's see. Algebra 1, Unit 2. And, let's see. I guess technically this is only page 1 of our notes. Unless you count this is a page, but whatever. I'm gonna not. Page 1.
We use the graph paper as page 2.
Yeah, we could use the graph paper as a page. So this could be your page 2, however you want to organize it. I'll call this page 1/2. Okay, so I'm going to also title this that it is our day 11 notes. And today we are talking all about finding slope, specific. Finding slope. Now, there are a few different ways that we have now learned to describe the slope. We can say that slope is the angle of the line, what angle it's going at. We can call slope, in our equation, it's the letter M. So I'm going to put an M here. And what's kind of the other way that we describe slope on a graph?
Run.
Yes, your rise over your run. Rise over run. Hi, Angel.
Hi.
You came just in time. We just started notes. Okay. Let me mark that you're here before I forget. Angel. Okay. All right, so we're finding slope today. Rise over run. Also M. Many different ways to describe slope. We're going to talk about how to find slope without a graph or an equation. I'm going to describe slope giving you a few coordinates. Okay, so this is how to find the slope of a line whenever you are just given coordinates. So I'm going to write passing through X, Y, and X, Y. So there's a way to find slope with a formula. And before I give you that formula, I'm going to color code my coordinates just because it'll stand out a little better which is which. And since we're looking at two different coordinates with two different x values and two different y values, we're actually going to name each specific x and each specific y so that we don't mix them up. So we call the first x x1. We call the second one x2. x1, x2. We call the first y, can you guess? y1. And the second y will be y2. The 1's go together, the 2's go together. You don't mix them up. We keep them separated by their number. So, we're going to use 2 coordinates to find slope using a fancy formula. M equals, here's the first part, M meaning slope. We're going to have y values first over x values. Whenever we do slope, we're counting the rise first, which tells us how far up or down we go. And when we're going up and down, we're going on the y-axis. So we're going to have the y's on top. So the first part of our formula will say y1 minus y2. Now here's where we do mix the numbers a little. So we have y1 minus y2, and then we draw a line as a fraction. We're going to make a fraction. And on the bottom, we have x1 minus x2. And we're going to just put it all in parentheses. And this formula we will use again and again and again and again. Highlight it in your notes. Don't lose it. Keep track of it. If it helps to put it on a really bright sticky note so you can move it to the next page when you need it, that's not a bad idea either. I'm going to do that myself. I'm going to just rewrite it on a sticky note so I can move it around. y1, y2. And we're subtracting them over x1 minus x2. So I just wrote it really big so I can move this around as we do some examples together, and I don't have to keep moving my paper up and down. So I'll leave that for a moment while everyone gets it copied into their notes, because this is important. And in my notes, I'm just going to write next to this real big, slope formula. I'm just keeping that to the side for now. And I'll just pause this, give everyone a moment to catch up to where we are, and then we're going to use this. So, I'm going to slide my page up and write a practice problem. And I'm going to keep this handy over to the side. So, for example, let's say that I give you these 2 coordinates. Let's start with 4, 3, and then we'll do 5, 10. We're going to find the slope of the line that goes through these points. So the very first thing that we want to do is we want to label our coordinates, because that is going to make it so much easier later on to figure out what number goes where. So in our coordinates, What comes first, the x or the y? The x. So I'm going to start by just writing x over both of my x's. And I'm also going to label my first coordinate with x1 and my second one with x2 to help me keep track. Now, the next coordinate spot is y. So, we'll label our y's. y1 goes with x1. y2 goes with x2. Once we have our coordinates labeled, we can start to use our formula. So, let's start by drawing a line, and I like to begin with the parentheses, and I want to go ahead and put the minus sign in the middle, because this is where I see the most mistakes, is students accidentally adding the numbers. Just start right off the bat with your empty parentheses and your minus. Start with that. So let's look at our formula. The first half, the top, we have y1 minus y2. So our first space should have y1 in it. What is my value for y1? 3. So I'm going to take that 3 and put it in the y1 spot. What comes next in the formula? y2. We just plugged in our y1. So next is y2. What's the value of y2? 10. So I'm going to take that 10 and I'm going to write it down here. Perfect. So I'm done with my y's. Now let's look at our x values. On the bottom of our problem here, x1 comes first. So let's write x1. What's the value of x1? 4. Perfect. And we've already got minus. Now we need x2. What's that? 5. All right, we plugged everything in. That's the hardest part. If that felt easy, good. You're going to be good at this. All right. If it didn't feel easy, no need to worry. This is the first time I'm showing you this, and it will get easier. So, once you have your numbers plugged in, we're halfway there. All we need to do now is solve both of these subtraction problems. What is 3 minus 10? Negative 7. What is 4 minus 5? Negative 1. If I have a negative over a negative, what does it become? A positive. So, we are going to move one step further and say that our slope is 7 over 1, or we could even just say that it's 7. And that would be our answer. So we just plug the numbers in, we solve 2 subtraction problems, and then we simplify. Okay, let's do another one. I'd like to show you a couple. And then see how we're feeling. So there's our first example. This would mean that the slope of the line that goes through these points is 7. Up 7 over 1. So here's another example. let's try some negative numbers. Let's do 2 and 5 for our first coordinate. And for our second coordinate, let's do -3 and -11. In the last problem, what was the very first thing we did?
Put down your parentheses.
Put down our parentheses. We could absolutely start with that. Let's do that. We're going to write empty parentheses with minus in the middle of it, with a line here. Boom. Okay. So I've got my empty parentheses.
Label the.
Yes. Yes, that is one of the most important steps. Don't try plugging these in without labeling them. You think you can do it. I promise it's going to feel silly to sit and label all of them, but it will prevent so many mistakes at the end. You think you can do it. I think I can do it, but I sit down and do it and you start mixing stuff up. It's so easy to mix it up. Just label them. It takes literally a minute, probably less. So, which value comes first?
2y.
My 2 here, is this x or y?
X.
X1. That's okay, that's okay. My question was not very clear. Okay, so if this is x1, then -3 would be x2. Okay, so now let's do our y's. What's 5 going to be? y1. And -11 is y2. So I'm going to move this down and use it to help me. So we have all of our numbers labeled. We have our empty parentheses ready to go. Okay. Now that we're ready to start putting numbers in the empty spaces, what comes first here? My 2? Ooh, so our formula says that on top, the y's come first. So we want to look at y first. That's 5. y1 is 5. Okay, so we have 5. Now, what comes next? -11. Just because there's already a minus sign here doesn't mean you write +11. y2 is still -11. So we're going to keep the minus. It'll be 5 minus -11. Okay? And that's important later. So we plugged in our y's. Which x goes first? 2. There's x1. We'll write 2. And what comes next? -3. -3. Okay. So we have all of our numbers in our problem. We have 2 subtraction problems. 5 minus -11 and 2 minus -3. Let's remember way back to pre-algebra for a minute. What happens when I subtract a negative number? It feels unnatural. It becomes a positive. What? Anytime you have minus a negative, remember the thing I told you about how there's these 2 minus signs and they're so close to each other, they like each other, they jump on top, they turn into a plus. This here, 5 minus -11, it feels wrong, but it's the same thing as 5 plus 11. That's weird. It's going to be 16. And watch this. When I type in my calculator 5 plus 11, I get 16. We know that. I should get the same thing when I type this. 5 minus negative 11. I get 16. It don't feel right, but it is. Minus a negative, it makes it behave opposite. Negative means opposite. So now we have 5 plus 11. And 5 plus 11, we just found out, is 16. Okay. So now we have 2 minus negative 3. What does that turn into? Turns into positive 5 because we have 2 minus negative 3, and that becomes 2 plus 3. If you see two minuses besides each other, or a minus and a negative, I can just, boom, positive. Positive. It's the same. It doesn't feel right, but it is. So 2 plus 3 is 5. Okay. We see how we did that? It's weird. So this is our slope. Because I don't think we can simplify that, can we? I don't think we can. That's our slope. It's a weird slope, but it's our slope. Let's do a few more with those negative, minus negatives, because that's a good thing to get in our brains. Now, before we start doing more, I do want to open the floor to you guys. Do we have any questions about the last two problems we just did? Any questions at all? Okay. Can I move this? All right. Let's do a little more. Page 2. And algebra 1. Okay, and I'm just gonna keep this sticky note nearby. That's why I like writing on sticky notes. We can move it around, you know, it's nice. Okay, so another example. Now let's try 0, 6, and negative 4, negative 10. Okay. Very first thing we should do is what? Let's label everything. Label everything. That's the best way to start. So let's start with our first value. We've got 0. What will that be labeled as? X1. Let's do our other x. What's our other x? Negative 4. That'll be x2. So how do I label 6? Y1. And negative 10. Y2. Y2. You're okay. Okay, so we have everything labeled. Now what? Bring it down? What am I bringing down? Where am I putting them?
Your parentheses and your.
I gotta do my parentheses first. I will highly suggest do this before you start rewriting your numbers. Obviously, everybody has their own method. If you don't do parentheses first, that's fine. You do it however you want. But this is how I'm going to recommend that you do it, because I've seen the mistakes that some of us end up making, and I think watching people do it this way has prevented the most mistakes. Just start by giving yourself the best possible chance at doing it right. Okay, so I've got my parentheses. Now I'm looking at my formula, the top, y1 minus y2. What goes in my first spot? 6. Okay. What goes in my next spot? Negative 10. So I have 6 minus negative 10. And now I'm going to move to the bottom. What goes in the first spot? 0. Okay, and last but not least? Negative 4. Good. Okay. 6 minus negative 10. What is the same thing as minus negative 10 at the end of this? 6 plus 10. That minus negative is going to turn into a plus. It's the same thing as 6 plus 10. Okay. What is 6 plus 10?
16.
16. Okay. Now I have 0 minus negative 4. What's going to happen here? It's turning into plus positive. It is actually 0 plus 4, which is 4. Can I simplify?
Yes.
Yes. Yes. 16 divided by 4 is 4. This is my slope. My slope is 4. Okay.
I'm sorry, that's a lot of work, that's for.
I know it. It is. But you're doing it.
Yep.
You're doing it. You're doing it really well. You guys got this. Okay. Now, we have done 3 examples together. Before I give you a few to try on your own, I want you guys, again, as a class, I want to hear at least 2 questions about what we just did. So even if you get it really well, you're like, this is easy. Try to come up with something that you think will help a classmate. I want 2 questions. So think.
I got one.
Yes.
Do we really need this in everyday life?
Well, no. Unless you are like an engineer or something, you know.
Which most of us probably do.
Depends on your lives. Depends on your lives. Any questions about the process?
It's a long process.
It is a long process. But it gets faster whenever we get more comfortable with it.
Once you get that.
I'm intentionally making it really slow right now so that nobody gets lost during the teaching of it.
Process of learning.
Yes, exactly. Nobody can think of a question? Does that mean you all are experts at this?
Nope.
What do you guys think is the hardest part of this process? What is like the hardest step?
The Y1 and X1 and.
Labeling them? Okay, labeling them. Oh my gosh. If that's the hardest part, you're going to be so good at this because that will become the easiest part so fast. It will. We're going to do so much practice with it. Promise you. Rhonda?
Mine is the minus and then the negative.
The minus negative.
And then turn it into a
Which is
positive.
literally what I was.
Right. It feels wrong, doesn't it? It feels weird. Like I don't, it's really tough for me to explain as a teacher. Because it's weird. But I think there are certain things in math that it's like really the more you do them, they start to become second nature. It really will start to be like, oh yeah, I know that. Minus, minus, plus.
But in
Like,
a way, it kind of goes back to, I know it was pre-algebra, I can't remember which term.
Yes.
Right, but it kind of reminds me of that a little bit.
It totally is. We had a whole like 2-week lesson about this specifically in pre-algebra. We spent a lot of time focusing on this because it's hard. Like it feels unnatural. It's different. It's odd. And it doesn't make a lot of sense unless we get really deep into the theory of it. And in the process of that, I might make it make less sense.
Right.
But I understand labeling and keeping track of what is what, and then remembering those weird rules. Those are definitely 2 tough things about this process for sure.
I literally learned about that in my pre-algebra class that I had, it was like probably a couple weeks before Christmas, I started to like actually get it.
Right.
I've been out of practice, so I'm forgetting a whole bunch of those rules. As soon
Right.
as you said that, I was like, oh my God.
Yep.
That's
Oh yeah, it all comes back. It comes back
Yeah.
sometimes. But maybe let's think about it this way. I'm going to try to put it in a different perspective. Let's think about the real world. Let's say I'm going to use a different piece of paper. And this is not going to be like yesterday. That was, yeah. So let's say I have $10. Okay, that's how much money I have. It's a lot. And if I subtract something, any amount, let's say I subtract $2, I'm taking $2 away. Subtracting is taking away. I know that $10, if I take away 2, I'm left with $8. Basically what's happening here is I have, and don't think of this as multiplication, I'm not multiplying these. I have 10 and I have -2. 10 and -2, this is like a charge of $2. Overall creates a total of $8. When I put these together, they give me -8. So let's see. Now if I have $10, let's say I want to take away the -2. Or I'm taking away 2. Actually, that's weird. That's weird, because I'm trying to think about, in my brain, my first thought is I'm taking away the charge of $2. That means we're just going to get rid of it, right? That's what my thought process goes to. Say it again.
That's how you're giving it back.
It's like we're kind of giving it back. Let's think of it like this, though, okay? You guys might recall, we've talked about before, like if I have, over here, -1 times -3. -1 times -3. What is that? It becomes +3. Whenever there's not a number, we assume 1. So minus -3. Okay. Look at this. A minus outside of -3. This is also +3. All we're doing is taking away the parentheses. Minus -3 now is the same thing as +3. So we'll kind of think of it that way. If it helps, we're going to kind of think of this as distribution. We're distributing the negative. Negative goes to there, just like we distribute -1. We're distributing this one to here, and it's changing it to a plus every time. You could also, instead of, let's see, like whenever you put your numbers in here, you've got your minus, minus. If I had like 3 minus -4, maybe it would make it easier to remember, maybe it wouldn't, if you put parentheses around your negative number. Because then you think, oh, well, there's a minus outside of the parentheses. These are going to go together and become 3 plus 4, a +4. So I'm just trying to think of ways for us to wrap our minds around it.
I don't know.
And maybe this didn't help at all. Maybe it didn't. It's confusing.
12, is that 12? What is that? What is that, what's the answer?
For this,
No, the 10 and the 2.
it's 12. Yes. This is the same thing. The minus -2, distributing it, it becomes $10 plus $2. So it's 12. Thank you. I get off track. I forgot we were even doing a problem. So, the minus negative is a plus, which is, it's something that either makes sense to you or you gotta memorize it. It's one of those things. I feel like I could try to explain it in a million different ways, and it is something that I mean, I have a hard time wrapping my head around it, and I studied math in college. You know, it's a tricky thing to get. It's just one of those things that we do.
That ain't even in school.
Yeah, it's a thing. It's a thing. Okay, I'm gonna move this.
Thank you for taking the time to do that.
Yeah.
About it, I feel like some of us really needed it.
Well, I hope it helped a little and didn't make it worse. That's never my goal, is to make it worse, but, you know, I'm always happy to take the time to try to explain. But I appreciate you appreciating it. It definitely feels nice, like, when I get reassurance that, like, okay, this helped somebody, because sometimes I feel like I'm explaining and it's making things worse.
No, you're literally the best math teacher.
Oh,
Yeah.
you're so
Not
sweet.
even kidding.
Thank you. That is so kind.
You explain it better than a lot.
Thank you. I try. Okay, do we want to do just one more together? One more together. Let's do another one with negatives. We're just going to get that racked in our brains. Okay, let's do 3, 5, -7, -9. Okay, 3, 5, -7, -9.
Label.
We're going to label them right off the bat. We know this is the first coordinate, so we're going to have ones. The only thing we really cannot get mixed up is that x comes first, always. X, y. X1, y1. Okay, so how will I label my 3?
X1.
X1. How will I label my 5? Y1. How will I label -7? X2. And Y2 for -9. Good. X1, Y1, X2, Y2. It will always follow that pattern. You won't ever have to switch them up in any way. So, now I have everything labeled. What should I do next? My parentheses. I'm going to give myself a nice space to plug my numbers into. Parentheses with the minus in between them. Okay. And we're going to keep our formula in mind. Yes. So we'll start with Y1, which is 5. What comes next? -9, or Y2. Okay. And on the bottom? 3. Good. Minus -7. Good. And I'm just really just circling these so you can see where they came from, but you'll notice as you work these out on your own, they will not necessarily take near as long because you're not asking questions as you go. So now we have all our numbers plugged in, and we just need to solve the top and the bottom.
It'll actually be 5 plus 9.
Yes, 5 minus negative 9 is the same thing as 5 plus 9, which is the same thing as 14. Okay?
That's what I'm getting mixed up.
Yes, and
The y is the x before,
so what will help, I think, and I was telling everybody, I can't remember if you were in here yet or not. Write your formula just huge on a sticky note and bring it with you for every question like this. Because that way I can just stick it right beside and I can just double check. I'm like, okay, my
And then
Y
also, I
one.
think what's confusing me now is I'm using the same colors, but I have mine backwards.
Oh, yeah, that would be confusing.
My Y is red and my X is blue. So
So I will never change the color of my X and Y, so it probably will get confusing if you're using the opposite colors. You don't have to do what I'm doing, but I bet it would really help to do the colors I'm doing, since it'll be like this forever. That's okay.
So now that's where I'm confused, like
The colors
I keep
mixing
writing
you
the
up.
Y first.
You are
My
supposed to
Y
write.
is- Because my Y is red, so I keep writing
Oh, okay. I get you. I get you. Yes. Okay, so we have our 5 minus negative 9, 5 plus 9, 14. How about the bottom?
It's the same as 3 plus 7.
Yes.
10.
It's basically 3 plus 7. It is 3 plus 7. It's 10. Okay, 14 over 10. Can we simplify?
Simplify, divide by 2.
Ooh, yeah, let's divide both of these by 2 to simplify. And what's 14 divided by 2? 7. 10 divided by 2? 5. These are both prime numbers. We're done. That's our slope. Very nice. If you kept it at 14 over 10, you're not going to get it wrong. This is also correct. So this is not, I'm not testing you on if you can simplify a fraction. It is a nice skill to have, and it, could be helpful at some point in your life. I couldn't tell you when, but it might be. But this is the simplified fraction. This is also correct. I'll take it. The only thing that you would get counted wrong for not simplifying would be if you get, let me find the problem where this happened. The very first example where we got negative 7 over negative 1, you would have to know that this is a positive. A negative divided by a negative is a positive. If you leave the negative signs there, I will count it wrong. Not completely wrong. It'll be like a half point for not doing that, but keep that in mind. That's the only thing. Everything else is fine. Okay. Okay. Can we try one on our own? Okay. Let's try one by yourself. Try it. Okay. Find the slope. And the coordinate I will give you, coordinates, let's do 4, 12, negative 3, and negative 5. Okay. Try this on your own. Use the formula. I'll pause our video and I'm going to set a little bit of time on the board. Well, I'm not going to set a timer. I think I'm just going to wait until we're all ready to look at it together. So, let's see. I'm going to start by labeling my coordinates. X1, X2, Y1, Y2. Okay, so give myself my parentheses with my minus in between. What comes first? 12, my Y1. Next? Negative 5, Y2. Bottoms, now I got 4, my x1, -3, x2. Perfect. Okay. 12 minus -5. What is that the same as? 12 plus 5. What's 12 plus 5? 17. 4 minus -3. It's really just 4 plus 3. Good. Which is 7. That's your answer. When we get quick, not when we get quick. When we get better at it, it does get quicker. It does. It felt really long when we learned it, but you see it gets a little faster as we go. Any questions? Did anybody not get this answer?
I got it backwards.
You got it
I
backwards?
have the exact same answer, just backwards.
Just flipped it. Okay. So you got the numbers. It'll just be more practice getting them in the right spot.
I don't even think it's that at the moment because my y, because when you look at I got the y's at the top and the x's at the bottom.
Uh-huh.
So I don't.
So what numbers do you have written at the top?
I have 4 and 3.
4 and 3 are the x's. Brian.
See, that's where that's why I'm getting, I don't know, that's why I'm getting confused.
Okay.
The paper
So,
says the x's are going to be at the bottom.
yes, the x's are supposed to be at the bottom. And you said that you have 4 and -3 at the top,
Okay.
but those are the x's. And I know, is it because your colors are still flip-flop? Oh, I know, that would definitely make it confusing.
I'll never do that again. I'm gonna.
That's okay. That's okay. Hey, this is the first day we've done this, and it's super easy to mix these up. You're doing great. The colors are to blame. We'll blame it on the colors.
Yeah, I don't think that's the answer. Flips.
Okay. Are we ready for an exit ticket?
Yeah.
All right. I know. I'm sleepy too. We gotta just wrap this up.
It's like just today, I've been so sleepy.
I think it's this weather.
But I forgot though, my husband switched shifts.
That
So I'm
affects
getting up
things.
at 6 now, because he has to be at work at 8.
Ooh.
I'm like, why you switch shift?
What shift was he working originally?
He was still working mornings, but he had to work at 9:30.
Ah, see that little bit of time makes a difference. It does.
I have to rush and drink my coffee.
Right. Right. Okay. I will make copies of this if anybody would rather wait for the copy. Up to y'all. Yeah, give yourself a little break because there's a lot of writing to do. So this is the day 11 exit ticket. And the directions are find the slope of the line that passes through and this is how the question will be asked whenever we are quizzed over it eventually. So find the slope of the line that passes through the given coordinates. And those coordinates are 3, 7, and -5, -3. And that's it. This will be due on Friday, but I'm sure you could finish it today before you go. I bet you can. And I am going to make a copy of this for anybody that wants it. So I will end our recording there. And that's it.